All right, chapter 9, section 1, Pythagorean Theorem. Please make sure you guys study this. The rules are pretty easy, but just make sure, again, you know how to use the calculator, because I will not help you with the calculator come day of your quiz or test. So please make sure you guys are using it in class and at home. All right, Pythagorean Theorem. Pythagorean theorems are only used in a right triangle. It's the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. We should know what the legs are. And hopefully we know what the hypotenuse is. Does anybody know what the hypotenuse is? Can anybody tell me what the hypotenuse is? Yeah.
The longest side of the triangle.
Good. So if I'm looking at this diagram, my longest side is going to be C. This is the longest side of my triangle. This is my hypotenuse. So anytime I'm plugging it into this formula, this rule, your longest side has to go here. So this is my longest side, and your C has to go there, okay? Your A and your B, you could switch them. It doesn't matter. But what matters is your C. Again, this must be the hypotenuse. That's the only thing that really matters. And again, everything is squared no matter what they're giving you. All right, common triples. Common triples are integers. They must be integers. Okay, you cannot have a common triple and have a square root. It has to be integers. Okay, only whole numbers. There are plenty of common triples. These are the first 5 that you should memorize, should hopefully remember with practice. And again, your longest side, so the largest number, is always your hypotenuse. Okay, so in my formula, in my rule, my Pythagorean theorem, this is going to be my C. Looking at it, if I were to draw a right triangle, please be aware, if it was to give you a 3, 4, 5 triangle, it could not be written like this. Why? Because, again, your longest side has to be your largest number, and that's opposite of your right angle. Okay, opposite of your right angle is always your hypotenuse. So again, your hypotenuse must be, it has to be the biggest number. God bless you. Okay, it has to be the biggest number. All right, before we start doing these examples, a couple things you have to know for big ideas is how you're writing your answer. If it's telling you give an exact answer, it has to be in simplest radical form. And then if it's asking you to round, most of the time it will be asking you to round to the 10th place. Okay, unless it's telling you otherwise. Rounding is rounding to the 10th place. Again, exact is in simplest radical form. If you cannot simplify it, leave it. Okay, so please understand that you will have to simplify on your test and quiz. So your calculators cannot simplify it for you. You have to do that by yourself. So please make sure you remember how to simplify. All right, they want us to find the values of x and y. Okay, so these are right triangles, so I am using my Pythagorean theorem, a squared plus b squared equals c squared. So let's go ahead and look at a first. Looking at a, I'm solving for my hypotenuse. I'm solving for my y. So I'm going to have for a, 5 squared plus 10 squared equals y squared. You guys have a calculator, you can use it. However, this one's pretty easy. Keep in mind, 5 squared is not 5 times 2. 5 squared is 5 times 5. So what's 5 times 5, or 5 squared? Good, I'm going to get 25. Plus, what's 10 squared? 100, that one's pretty easy. Equals y squared. I'm going to go ahead and add these. I'm going to get 125 equals y squared. I need my y by itself. Can anybody tell me how would I get rid of the squared? Good, I'm going to square root it. That's going to cancel out my square. That's how I'm getting rid of it. So if I do it to one side of my equal sign, I have to do it to the other. Is the square root of 25 a perfect root? No. So I have to simplify it. If you plugged it into your calculator, you would have had a decimal. I need an exact answer. So pay attention to how I'm simplifying my radical. If we forgot, hopefully we didn't, I'm going to factor it out. What two numbers give me 125? Good. I have 5 and 25. Keep in mind, I'm keeping it in the radical. I did not take it out. The only time I'm taking it out of my radical is when I get a whole number. Are any of these perfect roots? Yes, 25 is. And what's the square root of 25? 5. So now I'm taking it out. Now I have my answer. So solving it, my answer is going to be y equals 5 radical 5. Okay, again, you have to know how to simplify a radical. You are required to do that on your homework and on your test. All right, I'm just going to go ahead and do C right above it, and then I'll go over and do B. So looking at C, what is my hypotenuse for C? Sorry? 3 radical 2. So I'm setting up C as x squared plus 3 squared equals 3 radical 2. Everything is in parentheses squared. So solving it out, I'm solving for x. X squared is staying the same, plus 3 squared is going to give me 9. And now I have to go ahead and evaluate 3 radical 2 squared. So I'm going to go ahead and solve it over here. I'm going to have 3 radical 2 squared. I'm going to go ahead and I'm going to distribute my 2, my squared. 3 squared is 9. And I'm squaring a square root. That's going to cancel out. Or you could think of it as square root 4, which is a perfect root. I'm going to get 9 times 2, which gives me 18. Okay, or you could think of it as I'm squaring a square root. These are going to cancel out, and I'm going to get 2 left over. So, plugging it in over here, I'm going to have 18. And then I'm solving for x. I'm subtracting 9 from both sides. I'm going to get x equals, or x squared equals 9. And again, how do I get rid of that squared? Square root it. So what I do to one side of my equal sign, I have to do to the other. And x is going to equal 3. Good. 9 is a perfect root. All right, going over to B. Same thing. Again, you guys should hopefully kind of see the idea of this setup. I'm going to have 5 squared plus y minus 1 squared equals y squared. I cannot just distribute my 2. This one I have to FOIL. So 5 squared, I know I'm going to get 25. And then I'm going to go ahead and FOIL it up here. I'm going to have y minus 1 times y minus 1. And y times y is y squared. Y times negative 1 is negative y. Negative 1 times y is negative y. Negative 1 times negative 1 is positive 1. This changes to negative 2y, and then bring everything else down. So, writing what I have, 25 plus y squared minus 2y plus 1 equals y squared. And I'm solving for y. So looking at this, there are quite a few ways to start. However, can someone give me one way? How would I solve for y here? What do I have to do first? Looking at it, what do you want to do first? Yeah. I'm sorry? I'm not square rooting anything. I'm just evaluating it. I'm just solving for y. I don't have to get rid of anything yet. So what do we have to do looking at something like this? What do we have to do? What can we do? I'm going to combine like terms first. So what are my like terms? Good, 25 and 1. So right here, 25 and 1. I'm going to go ahead and get 26. Then I'm going to have plus y squared minus 2y equals y squared. Now what can I do? Jonah?
Cancel out the y squared.
Okay, I could move the y squared. I'm going to subtract y squared. So I'm going to have 26 minus 2y equals 0. Again, I'm trying to get y by itself. Now what can I do? Yeah. Good, I'm going to add 2y to both sides of my equal sign. I'm then going to have 26 equals 2y. And last, what should I do? Yep. Divide by 2. Good. So what's my answer for y? Y equals 13. Good job. Okay, so y equals 13. All right, so again, please make sure you know how to simplify radicals. It's super important for this lesson. All right, example number 2, it says find the length of the diagonal of a rectangle with width 8 or length 8 and width 4. For this lesson, or for this question, we have to remember properties of quadrilaterals. We just went over these. Rectangles. Okay, drawing my rectangle. I know it's a right, all my angles are right angles because it's a rectangle. And then they told me specific pieces of information. They told me that my length is 8 and my width is 4. So they want to find the measure of a diagonal, which is right here. And if I were to redraw this, I do have a right triangle. So here's my right triangle. Here's my 4, here's my 8, and I'm solving for my hypotenuse, which is C. So looking at it, plugging it into what we have, we're going to have a squared, which I'm going to make 8 squared, plus 4 squared equals C squared. 8 squared, we're going to have 16 plus, nope, let me fix that. We're going to have 64 plus 16 equals C squared. Adding these two, I'm going to get 80 equals C squared. Getting rid of my squared, I'm square rooting. Is the square root of 80 perfect root? No. So we have to simplify it. So simplifying it, I'm going to use 16 and 5. You could use any numbers, okay? But you're going to just have more work. Why am I using 16 and 5? Because I know 16 is the perfect root. This is going to give me 4. So I know my hypotenuse equals 4 radical 5. Okay, so looking at this one, my C, my hypotenuse, my diagonal is 4 radical 5. Yes?
How would you have done it if you divided the 80 into 10 and 8?
Okay, so I'll do that. Okay, so she asked, what happens if for 80 I were to use 10 and 8? So I'm going to go ahead and show you. Let's try that one out. Okay, I'm going to break it up into 10 and 8. None of these are perfect roots. Can I continue evaluating it? Yes. 5, I can do 5 and 2. Keep in mind they're still in the roots. Okay, they're still in radicals because they're not perfect roots. And then for 8, I'm going to have 4 and 2. Are any of these perfect roots? 4 is, so I'm going to take it out. And then I have 2 of the same ones. Okay, so right here I'm underlining them in blue. What's the square root of 2 times the square root of 2? That's going to give me the square root of 4, which is still a perfect root. So what do I have left over? I'm going to have 2 times the square root of 5. 2 and 2 is 4, and I still have the square root of 5 left over. So it still works. If you're looking at it, it's more of a longer process, but you're still getting to the same answer. Again, if you know your perfect roots, it should be a lot easier. Okay, and the calculator cannot simplify radicals for you. So do not rely on the calculator. If it says exact answer, it has to be simplified. Yes?
What about splitting it into 4D and 2?
It still works. If you want to try a different number, try it and I'll check it. But regardless of what numbers you're using, you'll still end up getting to 4 radical 5. All right, looking at example 3, it says the diagonals of a rhombus have length 16 and 30. Find the perimeter of the rhombus. So again, we have a rhombus. We have to know the properties of a rhombus. So looking at my rhombus, my diagonals are 16, and here is 90 degrees. I'm going to break that 16 up. I'm going to have 8 and 15. They want me to find the perimeter of my rhombus. So if I'm looking at it, I'm going to look at this as if I have a right triangle. I'm going to try and solve for my hypotenuse x. So here is my right triangle. I have 8. I have 15. Here's my right angle. This is my hypotenuse, and that's what I'm solving for. Again, you have to make sure you know where your hypotenuse is. So I'm going to have 8 squared plus 15 squared equals x squared. 8 squared, like before, we have 64 plus 15 squared. You guys have your calculators. You could plug it in. You're going to get 225 equals x squared. Adding these two together, 289 equals x squared. And again, how do I get rid of that squared? Square root it. Plugging it into your calculators, is it a perfect root? If you don't know how to use it on the calculator, that squared button, you could see the square root on the physical calculator. What you're going to do is you're going to push second squared. That should give you the square root symbol, and then type in your number. So please make sure you know how to push it. So what does it look like on your calculator? You're going to push that second button. Then you're going to push that x squared. So on your calculator, when you do that, something that looks like this should pop up. Then you put your numbers in. Okay, is 289 a perfect root? Yes, so what would my answer be? X equals 17. Were they asking me for my hypotenuse or x? No, they're asking me for my perimeter. So I have 17, 17, 17, and 17. You could just plug into your calculator 17 times 4. If you solved it correctly, your perimeter is 68. All right, looking at example 4, it's asking me to solve for x. Looking at this entire triangle, this is not a right triangle. However, they are splitting it down the middle. Okay, so they're making perpendicular angles right here. So looking at this, they're telling me that this entire segment is 6. But I don't need the entire segment. I'm only looking at my right triangles. So right here. So what would I have for the base of that triangle? Good, I'm breaking it into 3 and 3. So if you would like to redraw it, that's up to you. I'm going to go ahead and just redraw it. I'm going to have 3, 6, and x. X is my hypotenuse. So I'm going to go ahead and I'm solving for x. How would I set this up as an equation? How would I set this up as my equation? Yes.
3 squared.
3 squared. Mm-hmm. Uh-huh. Good. This is how it should be set up. So solving it, these are small numbers. You don't necessarily need your calculator. You're going to have 9 plus 36 equals x squared. Adding, I'm going to get 45 equals x squared. Getting rid of that squared, I'm going to go ahead and square root it. And then is the square root of 45 a whole number? Is it a perfect root? No. Go ahead and simplify it. I'm going to give you a few minutes to simplify it, and then we're going to check it. All right, checking our work for this one. This one was not a large number, so you're really limited on numbers to use. So simplifying these, which two numbers did you use? Good, 9 and 5. So the square root of 9 and the square root of 5, are any of these perfect roots? 9. So what did you get for 9? 3. So my answer for my hypotenuse is 3 radical 5. Okay, I think we all got there. Looking at some of yours, I think we're good. Okay, questions? Okay. All right, yes, there is a theorem here, but again, there will not be proofs for this lesson, but you have to know this, okay? Now we're doing the converse of Pythagorean theorem. Now we have to determine, is the triangle right, obtuse, or acute, okay? Using the information of my sides, okay, the sides of my triangles. So, key thing here, if your longest side is equal to, this one's pretty easy, the sum of the other two sides, it's a right triangle, okay? If your longest side is equal to the other two sides, it's a right triangle. So that one's pretty easy, that one we should know, because Pythagorean theorem is only used for right triangles. Looking at the next one, if the longest side is less than the other two sides, it's an acute triangle. So again, you have the longest side. If it's less than, it's acute. So we have to kind of figure out what the last one is going to be. So looking at the last one, if the longest side is greater than the other two sides, it's obtuse. Okay, so if it's less than, it's acute. If it's greater than, it's obtuse. So when I'm solving these, I'm going to write my longest side first, so I kind of have it in the same format, okay? So we could kind of use the same signs. All right, look at these examples. They want us to determine if it's acute, right, or obtuse. So looking at it, I'm going to go ahead and do A first. So the same setup that they gave us in the theorems, I'm going to do my longest side first. So I'm going to take 29 squared. I need to determine if it's less than, equal to, or greater than 20 squared plus 21 squared. Again, you guys will have calculators, so it should be pretty easy and quick to punch these in. Again, you have to show work for your homework and on your tests and quizzes. So showing my work. Plugging it into the calculator, 29 squared is going to give me 841. And then you can do these separately. I highly recommend you guys do them separately so you know you're plugging it in correctly. 20 squared, you're going to get 400. Plus 21 squared is 441. Adding these two together, I'm going to get 841 is blank 841. They are equal. So what kind of triangle is this? Good. This is a right triangle. Looking at the next one, I'm going to have 30 squared. And I still have 20 squared plus 21 squared, so that one should be pretty easy. 30 squared, I'm going to have 900 is blank to 841. 900 is greater than, so what kind of triangle is this? Good, this is going to be an obtuse. Looking at C, I'm going to have 8 squared, and then 5 squared plus 6 squared. 8 squared is going to give me 64. Blank 25 plus 36. So I'm going to get 64. 61. What kind of triangle is this one? Good, this is still an obtuse. All right, looking at D. I'm going to have 8 squared. And then I'm going to have 4 squared. And then pay attention to how I'm writing the next one. Plus, in parentheses, 4 radical 3 squared. So 8 squared, I'm going to have 64. 4 squared, I'm going to have 16 plus. 4 squared is going to give me 16 times the square root and the square root cancel, so I'm going to have 3. Evaluating this, 64, 16 plus 16 times 3 is going to give me 48. So 64 blank, adding these two is still going to give me 64. So what kind of triangle is this one? This is also a right triangle. And then looking at the last one, which is C. I'm going to have the square root of 10 squared. And then I'm going to have 1 squared plus 3 squared. The squared and the square root are going to cancel, so I'm going to have 10. 1 squared is 1. 3 squared is 9. So I'm going to get 10 is equal to 10, and this is also a right triangle. So looking at these, there were no acute triangles here. All right, this is just everything summed up. Okay, so everything kind of put together. If they're equal, it's a right triangle. If your longest side is less than, it's acute. If it's greater than, it's obtuse.